Welcome back. We are starting chapter 6 today, and we're going to be talking about some properties of exponents, page 312 in your textbook if you want to follow along. And a couple of main ideas that we are going to hit on is to use the properties of exponents to be able to multiply and divide monomials, and to use expressions written in scientific notation. So first off, we need to talk about what a monomial is. We had this way back in chapter 1. And a monomial is a number or a variable or a product of both of those things. And some of the restrictions on monomials, they cannot contain variables in the denominator. They also cannot have variables with negative exponents. And they cannot have variables that are under a radical. If any of those three conditions occur, it is not a monomial. Okay, so you need to know what a monomial is before we can simplify those, okay? Simplifying monomials, what we mean when we say by simplify a monomial is to get rid of all of our parentheses and to get rid of all of our negative exponents. Here are some properties that I would like you to fill in your notes. If you have a number that's a base, any number a, and it's raised to a negative exponent, that means the same thing as the reciprocal of that number to the positive exponent. And an example would be 2 to the negative 3 is equal to 1 over 2 to the third. Okay. Likewise, this one over here where you start with the negative exponent in the denominator, the negative exponent just basically flips whatever number you have to the opposite place. If it's in the denominator, it goes to the numerator. If it's in the numerator, it goes to the denominator, and then you change the sign of the exponent. So 1 over a to the minus n is equal to a to the positive n. An example, 1 over b to the minus 8 is equal to b to the positive 8. Moving over to the right-hand side, if we have the same base multiplied together and they have different exponents, we add the exponents. That's a to the m plus n. An example is b to the third times b to the fifth is b to the eighth. You add the exponents. Likewise, when we divide, we will be subtracting, and here's an example there. X to the seventh divided by x to the third gives you x to the fourth. Power of a power, when we have something raised to a power in parentheses raised to another power, we multiply those powers. That's a to the m times n. An example would be a squared raised to the third is a to the sixth. Power of a product, whatever you have inside of parentheses raised to a power means you have to raise everything in the parentheses to that exponent. An example would be xy raised to the second. So x and y would both be squared in that example. Likewise, if you have a quotient raised to a power, everything inside the parenthesis gets raised to that exponent. And the restriction here obviously is b can't be 0 because we can't divide by 0. There's an example on the right. When we have a negative exponent, what that does is the b comes in the numerator and the a goes to the denominator, and they are both raised to the positive n power. Okay, so it flips those two around and it makes it to the positive n. And this time a cannot be 0 and b cannot be 0. Example for you on the right. And the 0 power, any number to the 0 power is equal to 1. And a cannot be 0. So any number at all to the 0 power gives you 1. Sorry about that there. See if we can get rid of this. Okay, here's an example of simplifying expressions. If we have two monomials here and we want to multiply them, that's what's implied by the parentheses next to each other, then what we can do is we can rearrange all of the numbers and regroup them according to similar terms. So we'd have 3 times the negative 4, and then we'd have x to the third times x squared, y squared times y to the fourth. Well, we could expand that all out and write x 3 times and then 2 more times, so we should have 5 of them. 1, 2, 3, 4, 5. And then y, we should have 6 of those, so that gives us negative 12, x to the fifth, y to the sixth. Over here on the right, rearranging those, a to the minus 3 is 1 over a to the 3, and c to the minus 1 is 1 over c, so those two will be in the denominators, but then we can simplify here. We have 1 over a times a squared is a times a, and then we have 4 b's, then we have 1 over c. Well, 2 of these a's will cancel with 2 of the a's in the denominator here. You see those lines in blue? And then we'll be left with an a in the denominator and a c in the denominator. So the b's will stay in the numerator, so we have b to the fourth divided by a times c. Here's your turn. Please pause the video, take some time to go ahead and try these on your own, and I'll give you the answers when we come back. All right, over on the left-hand side, multiplying those together gives us a positive 15, x to the fifth, y to the eighth. Remember, you're adding the exponent, and a negative times a negative gives us a positive. On the right-hand side, we end up with a negative 14 x squared y to the minus 3. But remember, we can't have any negative exponents. When we're simplifying, we have to have all positive exponents. So that puts that y to the third in the denominator. So our answer is minus 14x squared over y cubed. All right, here's some more examples of simplifying expressions. P to the third divided by p to the eighth. Well, that's going to be p to the 3 minus 8th, which is p to the minus 5th, which is 1 over p to the positive 5. Power to a power, remember we're multiplying here, so we get a to the 3 times 6, which is a to the 18th. Next one, we have a quotient raised to the fourth power. So remember, everything in here gets raised to that fourth exponent. So we have negative 3x to the fourth and y to the fourth. Negative 3 to the fourth, x to the fourth, y to the fourth. And negative 3 to the fourth gives us 81, x to the fourth over y to the fourth. Likewise, over on the right-hand side, these get really complicated here. So negative 2 raised to the fourth power, x to the 3n raised to the fourth. And down in the denominator, we have x to the 2n, y to the third, all raised to the fourth power, and we have to multiply these exponents down here. So negative 2 to the fourth should give us 16. X to the 3n raised to the fourth is x to the 12n. X to the 2n raised to the fourth, multiplying those, we get x to the 8n. And y to the third raised to the fourth, multiplying our exponents, is y to the 12th. And looking at that, let's see, what can we simplify? We have x to the 12n divided by x to the 8n, so we're going to subtract those when they're divided. Remember, 12n minus 8n gives us 4n right here. The 16 stays there, and the y to the 12th is in the denominator. So getting a little more complicated in some of those. Please pause the video and take some time to try these on your own. All right, on the left-hand side, you end up with 27 x to the 6th, y to the 3rd over 8x cubed, y to the 12th. And then simplifying again, these 3 x's will cancel with 3 of these, and there's 3 left in the numerator. On the y terms, the 3 in the numerator cancel with 3 in the denominator, and we're still left with 9 of those y's in the denominator. And it looks to me like we forgot that there's an 8 down here. So there's an error in here. Let me just correct that quickly. There should still be an 8 down here with y to the 9th. So sorry about that. Over on the right-hand side, simplifying that one. Negative 3 to the fourth power gives us 81. X to the minus 5 raised to the fourth is x to the minus 20. And then we get y to the minus 8n. In the denominator, 5 to the fourth power is 625. And x to the minus 6 raised to the fourth is x to the minus 24. And then we need to simplify. So we have a negative 20 minus a minus 24 up here. Makes it a negative 20 plus 24, which is where we get x to the fourth. Down here in the bottom, we have y to the minus 8n goes to the denominator and becomes y to the positive 8n. All right, simplified expressions. How do you know when you're done simplifying? You are done simplifying if there are no powers of powers, if each base appears only one time, if all the fractions are in simplest form, and there's no negative exponents. If all those conditions are met, you are done simplifying. So this is a good slide to make sure you have written down each of those 4 things. So when we come to test time, that'll help you out a little bit. And scientific notation. A number's in scientific notation when it's in this form. You have a number a times 10 to some power n, and the number a, the biggest restriction here is this number has to be bigger than 1, could be equal to 1, but it has to be less than 10. And n is an integer, no decimals or fractions. Remember, integers are positive or negative whole numbers. And one little piece of information we're going to need over here is the speed of light is 3 times 10 to the 8th meters per second. So astronomy, after the sun, the next closest star to Earth is Alpha Centauri C, which is 4 times 10 to the 16th meters away. How long does it take for that star to reach the Earth? Use the information at the left. Okay, so we're going to start with the formula. Distance is equal to rate times time. Okay, and we're going to solve that for time. So because the question said how long does it take light to reach the Earth, we're looking for time. So distance is given as 4 times 10 to the 16th. The rate is over here, 3 times 10 to the 8th. So we're going to divide those two numbers. And now that we have some properties working with exponents, we know how to do that. 10 to the 16th divided by 10 to the 8th is 10 to the 16 minus 8, which should just give us 10 to the 8th for our exponent. And 4 divided by 3 is 1.33. Since this number is between 1 and 10, we're good to go. So it's 1.33 times 10 to the 8th. And that's the end of our lesson. We'll see you next time.